Students, let us discuss exercise 13.1. Fifth sum. A hemispherical depression is cut out from one face of a cubical wooden block. The diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Actually, the hemispherical depression is cut out from one face of a cubical wooden block. Okay, actually, here cut out hemisphere from the cubical block. Okay, here I took that is the top side, cut out hemisphere from the cubical block. Then we need to find out the total surface area of the remaining solid. So that means we need to find out the surface area of 1, 2, 3, 4, 5 sides, and we need to find out the surface area of inside of the cube. Actually, the hemisphere is cut out from the cube. No? That cut out portion, okay, that also we need to find out. So first, here we need to find out the total surface area of the cube, plus we need to add the curved surface area of the hemisphere. Curved surface area of the hemisphere minus area of base, because this place we cut out. Okay, we cut out hemisphere from the cube. I hope you understood this concept. Here given the edge of the cube is L, so that means the radius of the hemisphere is L by 2. Okay, so you know the formula: surface area of cubical part. The total surface area of cube is 6 of each square plus curved surface area of the hemisphere, curved surface, 2 pi r square minus the top. Actually, the top is open. So pi r square. Thereafter, you substitute the values in the given formula: 6L square plus pi into L by 2 the whole square. So 6L square plus pi L square divided by 4. Then you take LCM. So LCM of 4 and 6 is, you know, the 24 L square plus pi L square. Then here, which is common? 4. After taking that LCM, denominator 4 is common, take outside. And L square is also common. So 1 by 4, 24 plus pi L square units square or square units. Because here we found the total surface area. Students, let's discuss exercise 13.1. Seventh sum. A tent is in the shape of cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered with canvas. Here given the slant height of the tent is 2.8 meter and height of the cylindrical portion is 2.1 meter, and the diameter of the cylinder is 4 meter. That means the radius of the cylinder is 2 meter and the radius of the cone is also 2 meter. Actually, here we need to find out the cost of the canvas. So for that, first we need to find out the total surface area of the tent. Okay, so for that, first we need to find out the curved surface area of the cylinder and the curved surface area of the cone. So already we know the formula for curved surface area of cone, pi rl, and curved surface area of that cylinder is 2 pi rh. So we know all the measurements, radius, slant height, and height of the cone, everything. Okay, so directly substitute in this formula. Pi rl plus 2 pi rh. Substitute the values. Pi into 2 into slant height is 2.8 plus 2 pi into 2 into 2.1. Then simplify. Here which is common? 2 pi is common, or else directly you can substitute the value 22 by 7, or take common 2 pi. At the same time, radius also you can take, or also common, or keep it as it is. So 2.8 plus 2 into 2.1. Then after simplification, you will be get 44 meter square. Okay, so area of canvas used 44 meter square. So already given the cost of 1 meter square canvas is rupees 500. Then the cost of 44 meter square canvas is 22,000. So therefore it will cost rupees 22,000 for making such a tent. Students, let's discuss exercise 13.18 sum. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Okay, so here actually that conical cavity is hollowed out, and that conical cavity, that radius and height are same to cylinder. So find the total surface area of the remaining solid to the nearest. Actually here we need to find out the total surface area. Okay, so for that, here we need to find out the curved surface area of the cylinder. At the same time, that surface area of conical cavity. So already actually this is solid. Okay, solid cylinder. From the solid cylinder only we cut out cone. So that means we need to find out the surface area of this cone. Okay, that inside area. So we need to find out the curved surface area of the cone, and we need to add these two areas: curved surface area of cylindrical part and plus curved surface area of conical part plus the base area of cylinder. So the base area is circle, because in this question they asked to find out the total surface area. Okay, so curved surface area of cylinder plus curved surface area of this cone and the base area of cylinder. So to find the curved surface area of a cone, we must know the slant height, but here we know the height of the cone and radius of the cone. So we need to find out the slant height. So already you know that how to find out the slant height. Slant height equal to square root of r square plus h square. The radius is 0.7, height is 2.4. Then simplify, you'll be get the answer as 2.5 centimeter. Thereafter, we need to apply all the values in the formula. Okay, so the total surface area of the remaining solid is curved surface area of cylinder part plus curved surface area of conical part plus area of cylindrical base. So you know the formula. 2 pi rh plus pi rl plus pi r square. Then substitute the values in the given formula. So at finally will be get 17.60 centimeter square. So the total surface area of the remaining solid to the nearest centimeter square is 18 centimeter square. Okay, so that is nearest value, that is round off. So 18 centimeter square. Students, let's discuss exercise 13.19. Some a wooden article was made by scooping out hemisphere from each end of a solid cylinder as shown in the given figure. If the height of the cylinder is 10 centimeter and its base radius 3.5 centimeter, find the total surface area of the article. Actually, from this question, the hemisphere scooping out from each end of solid cylinder. Actually, here we need to find out the total surface area of this article. So for this, first we need to find out the curved surface area of the cylinder, then curved surface area of these two hemisphere, or find curved surface area of one hemisphere, then multiplied by 2. Okay, so we need to add curved surface area of cylinder and 2 times of curved surface area of hemisphere. So surface area of article equal to curved surface area of cylinder part plus 2 times of curved surface area of hemispherical part, 2 pi rh plus 2 into 2 pi r square, because curved surface area of hemisphere. Okay, then substitute the values in the given formula. So at finally will be get 119 pi value 22 by 7, and 7 and 119 will be cancelled, so 17 into 22. So the answer is 374 centimeter square. For surface area of article is 374 centimeter square.